Today we're going to start talking about Unit 2 Worksheet 1c a little bit. We've got a fake set of wheel and axle data. We get started at a position of 0 and over the course of 6 seconds move to a position of 180 centimeters. You're asked to build a position versus time with that, position versus time graph. Make sure you've got a title of position versus time. Make sure you've labeled the y-axis with position, measured in centimeters, the x-axis and clock readings, measured in seconds. We've scaled the x-axis. Every 5 hash marks is equal to 1 second, and we scaled the y-axis or position axis with in 5 centimeter increments. Next, once you've plotted all 7 of your points, go ahead and draw your best fit line. The rest of your ability, and we've got a nice curve there. Question below says, what's the significance of the slope for the position versus time graph? We know that's the velocity. What's happening to the slope of the position versus time graph? It's getting steeper or it's increasing. And our fourth question asks, what does that tell us? That means the velocity is increasing. It tells us our wheel and axle is speeding up. On the next set of questions, it says, on the position versus time graph, draw a line from 0 to 6 seconds and then calculate the slope of the line in the space below. So to draw that line, you're going to want to pull out a ruler or use a tool like a drawing tool like a line from Cami, or I'm going to use this one on notebook, but I'm literally going to connect my points from 0 to 6 seconds. So I'm from position 0, at position 0, at time 0 we're at position 0, and at 6 seconds we're at 180 centimeters. So calculating the slope of that. Well, our second position in that case, 180 centimeters, minus our starting position, which is 0 centimeters. Our change in time for this one is 6 seconds minus 0 seconds. So it's 180 centimeters divided by 6 seconds, which equals 30 centimeters per second. The next question comes and says, explain what that represents. Well, if we're looking at the change in position divided by the change in time, what does that calculate? Ultimately, that means that's the average velocity from 0 to 6 seconds. Next up, they ask us to calculate that to draw a line from 2 to 4 seconds on the graph. We'll do that in blue this time. And so literally you're drawing a line that connects from 2 seconds to 4 seconds. Draw that line. Boom. Draw a line from the point 2 seconds to point at 4 seconds. Try to make that a little bit better. I'm going to change that to blue just so we can keep track of the properties. I'll make that one blue. And boom. So next, we would then take the coordinates. At 2 seconds, we were at 20 centimeters. And at 4 seconds, we were at 80 centimeters. And you would make that calculation here. Whoops. You'd want to make that calculation here. So the calculation of the slope from 2 to 4 seconds. And you'd want to continue with that similar work here. I hope that points you in the right direction.